So this is the post-lab analysis showing you how to work the problem to solve. You've got this data now from this yeast catalyzed peroxide decomposition. So the question now is, how do you work up the data? And so this will be a little walkthrough of how I would solve the data. Now the question, there is a little bit on this sheet that has to be explained. So originally we had done another calculation where we'd done mass difference. So if you see that little mass difference thing up at the top, you can just go ahead and ignore that. That was something we did in another lab. We're not going to do it in this one. We can get the number of moles from the ideal gas law. Okay, so this is a constant, right? Temperature, okay, you're going to measure. That's one of the steps that you're going to measure, right? So you're going to measure that. Okay, this then, the volume is the volume of the water that's displaced, right? Okay, so the complicating factor here then is the pressure. Okay, so the pressure turns out to be a little bit more complicated because what we really need is the pressure of the oxygen. Okay, now we know that if you think about the flask, right, the flask is pushing out. It's an open system, right? The beaker has open, so the total pressure, okay, is the atmospheric pressure. Okay, but we want to know the partial pressure of oxygen. Okay, so if we're thinking about the partial pressure of oxygen, the temptation might be to think, well, that's the thing that's being pushed out, so it's equal to atmospheric, and it's not quite, because if you think about the flask, okay, the flask has got, okay, if you think about the flask, okay, it's got O2 being pumped in, right? So that's the partial pressure of the O2, but then there's also the evaporated water, okay? So there's a little bit of water molecules in here. So the total pressure then is equal to the partial pressure of the oxygen plus the partial pressure of the water. And so that we can look up by looking up the vapor pressure. Okay, so if you think about the pressure of the O2 then is equal to the atmosphere, the barometric pressure, which you will measure. We have a barometer in the lab, and subtracting out the partial pressure of the water. Okay, now the partial pressure of the water can be looked up. It's temperature dependent. Okay, so you have to look at the temperature of the water. We'll just assume that the water that we measure outside this reaction doesn't get particularly hot is probably equal to the water temperature on the inside. But we need to look that table up. There's one in the lab manual for a small range of temperatures. If you need a little bit finer, because these thermometers do have 1/10 of a degree, you can probably find that online, or you could just extrapolate it from the table there. Either way is fine. Okay, so this will be a little bit trickier calculation. So you're going to have to calculate this first, then you can plug this in and you should be able to get in. Okay, and so the question then becomes, and so T of course needs to be in Kelvin. Okay, and volume should be in liters or whatever you're going to use, and P is in torr or millimeters of mercury.